Okay. Good morning or good afternoon, and a special welcome to all attendees for this Smart Grid and Distribution Innovation webinars. My name is Oscar Sigvaldason. I have the distinct honor of being your moderator for this very important and timely webinar. I'm here representing the Canadian Academy of Engineering, CAE, and in respect of my current role as chair of CAE's Future of Engineering Committee. The CAE is a National Academy of distinguished professional engineers in all fields of engineering who are elected on the basis of their distinguished service and contribution to society, to the country, and to the profession. Its mandate includes providing leadership on the responsible application of engineering knowledge for the benefit of Canadians, providing its strategic advice to decision makers, and contributing to shaping the future of engineering in Canada. Today's webinar is one of 4 quarterly webinars organized and presented each year by the CAE. Our webinar today addresses a very important subject. In its quest for reaching net zero emissions by the middle of this century, Canada will be embarking on the largest, most complex, and most expensive energy transformation program in its history. This includes a massive electrification program with projected up to 3-fold increases in electricity demand. There are major opportunities for reducing costs of electricity for consumers by using smart grid technologies within distribution utility organizations and by the ultimate consumers. This will lead to major changes in consumption and production of electricity by electricity distribution companies, as well as by individual homeowners and businesses. We are especially fortunate to have 3 leading Canadian experts with us today to speak to us on developing and applying smart grid technologies and distribution innovations in Canada. This webinar will begin with a 15-minute presentation by Eldridge Rebello from the Office of Energy and Efficiency R&D at Natural Resources Canada. Eldridge will be presenting information on how Canada supports energy innovation and clean tech solutions by providing support for research, development, and demonstration. This will be followed by a presentation by Hisham Omara, Vice President, Grid Modernization at Electra Utilities. He will give an overview presentation on grid modernization from the position of a dynamic distribution utility organization. The concluding presentation will be given by Ron Demon, Chief Operating Officer at DC Bell. His presentation will be on technology developments and how such developments will change home energy ecosystems. Each of the 3 presenters will very briefly self-introduce themselves at the start of their respective presentations. Following the 3 presentations, we will have 15 to 25 minutes for Q&A. We're asking attendees to enter their questions or brief comments in the Q&A section, as shown at the bottom of your screen. We will not be using the chat function on your screen. We look forward to a very interesting webinar, and without further ado, I now invite Eldridge to give the opening presentation.
Thanks, Oscar. Just going through the share screen motions here again. So hopefully everyone can just see the presentation slides. Could I get a thumbs up from one person and you're not seeing my presenter screen? Perfect. Okay, so my name is Eldridge Rebello. I'm with Natural Resources Canada, sometimes abbreviated as NRCan, not to be confused with NRC, which is the National Research Council. I'm with NRCan's Office of Energy R&D, and I've got a couple of introduction slides at a high level of what NRCan does. You'll see NRCan involved in lots of things, ranging from forestry maps to energy innovation. And if you happen to apply to the Greener Homes grant in the past couple of years for home energy retrofits, that was also an NRCan program. I'll skip the high-level details. I'll go straight to what I do at the Office of Energy R&D. So at the moment, I am acting Deputy Portfolio Director for the Smart Grid and Renewable Energy portfolio, and that is under NRCan's Office of Energy R&D. Broadly, we do a lot of work connected to energy research, development, RD&D funding in general. To give you some sort of sense of where we sit in the innovation or the research pipeline, we span the entire section between laboratory or basic research and commercialization on the right. So these three chevrons in between, that's where OERD works. Before we go into details of today's presentation, I just want to point out we do have an active call open. It's NRCan's Smart Grid program. The QR code on the right should take you straight to the application website. There are a couple of dates at the bottom. Unfortunately, these were info sessions and they happened last week. But not to worry, the recording should be on our website fairly soon. We've got two focus areas. One is technology demonstration. That's the application deadline closes on the 10th of January. And the other is regulatory innovation. So that's closing on the 31st. Unfortunately, I cannot take questions about this program today, but please do write to the email address at the bottom here. Someone from our team will get back to you. So getting into today's presentation here, I want to start with a bit of a provocative question here. More and more things are connecting to the electricity system. Now, there's a laundry list of what those things are, but the broader question here is, how much electricity do we need in the future? Please bear in mind, I'm using electricity interchangeably with electrical energy. So how much electrical energy will we need in the future? This on the right here, you can see a bunch of forecasts. Now, they all give you a different number depending on what their assumptions were, and there's considerable uncertainty in this. And of course, this looks different in different countries. But where they all agree is that tomorrow we will need more electricity than we currently consume. So as more and more things connect to the electricity system, whether they are electric vehicles, rooftop solar, whether it's batteries in at homes, controllable washing machines, all these things, all of these consume more electrical energy. And the common factor here is all of these connect at the distribution level. So this is leading to a significant change in what the distribution system was designed to do. And those changes are, so there's two primary ones here. The most important one is the distribution system specifically is moving from a passive participant in the electricity system to now an active participant. People are talking about two-way energy flows. So rooftop solar panels on my roof, for example, now pump electricity back into the grid. So these are significant changes, and historically, the distribution system has typically been viewed as poles and wires. So just a way of shoveling energy from the transmission system to homes, to businesses, to a lot of places. But this is flipping on its head now, and the role of the distribution system is becoming closer to the transmission system. And the second one here is human behavior. This is an interesting piece, and there's something I can suggest, but I do not recommend that you do, which is to dive into the comment sections on newspaper articles, especially ones that concern electricity or the energy system, electric vehicles. The reason I'm pointing to that is because those folks are equal participants on the electricity system as anyone else. Some of their concerns are justified. So my neighbors, for example, think that they believe that allowing their utility to control their thermostat will lead to their house turning into a sweatbox in the summer. Is it true? I'm guessing probably not, but it is certainly a valid concern. And this is where engineering and science run up against human behavior. This is a significant challenge, and especially if we are talking about a distribution system where things are changing quickly, this is an equally important part of the transition. Now we come to the question of what are smart grids. Now, unfortunately, I will not leave you with the concise definition at the end of this, because if you ask 5 people what a smart grid is, you will hear 6 different answers. But there are a couple of general themes here. One of them is data. Data for things like monitoring, visibility, what is happening on the distribution system, how much energy is being consumed, Who is consuming it? When are they consuming it? Do you have some ability to say, maybe we shouldn't have 30 people all charge their electric vehicles between 5 and 7 in the evening? Maybe that's not a good idea. Some folks might be flexible, maybe spread out the charging time a bit more. All of this requires two things. It requires communication, the ability to exchange data with devices on the electricity system, and the ability to control them. This is generally possible on the transmission system, but it's generally not possible, and it's generally not done on the distribution system. I will add a major caveat here. The words generally in those two sentences are doing a lot of lifting. Things are changing, and they are changing quickly. There's one other aspect I'll point to here, which is this idea of integrating energy resources onto the electricity system, specifically the distribution system. This is again another key feature of smart grids, in that in general, a smart grid will allow you to connect things like rooftop solar, maybe some geothermal sources, maybe a small combined heat and power turbine. There's a bunch of options here, but these are generally smaller generators, and they generally provide limited amounts of energy when compared to large, say, wind turbines, gas turbines, or hydro plants. But integrating these into the electricity system again requires what I said at the start, which is data and the ability to control them. There's one key factor here, which is energy regulation. Now, the electricity system in Canada is not regulated federally. Each province, each territory runs their own system based on their own needs. This creates a situation where a solution that might work in BC might not work in Nova Scotia. So at either end of the same country, maybe things don't work. So this is another area where we are also keeping we are keeping a close eye on how regulation is moving and which provinces are ahead in this game. Now I'll move quickly to our previous smart grid program. I will repeat, I did show you a slide at the start saying that we have an active call. Yes, we do. That is also called the smart grid program. This, what I'm sharing with you, is our previous smart grid program, and this ended. So I'm sharing results with you here. Very quickly, this was a $100 million program that ran between 2018 and 2013. So peak years of the pandemic, unfortunately, that led to some delays. We had 22 projects, including innovation, so demonstration and deployment. All of these links should work. So if you type NRCan Smart Grid Program into your favorite search engine, you should be able to find all of this information, including our smart grid brochures. I'll move quickly to some of the solutions we tested. There's a good spread ranging from simple monitoring and automation. I'm saying simple, but in the grand scheme of things, that's foundational to a lot of ideas. And on the other end, we looked at things like energy markets and rate design. So there's a mix here of technology solutions as well as things that involve regulation and markets. So I'll point to two examples to be specific. One here is DERs. So this is distributed energy resources. How do you integrate these onto a distribution grid? What can they do? Can they provide more than simply cheap energy? The answer often is yes, but then you end up with the other question of how. Can I sell electricity to my neighbor from my rooftop solar panels? Well, technically yes, but if the market and the regulations don't exist to allow that, well then functionally no. So there was a good spread of technologies and demonstrations that we tested. There's I on the previous slide I referred to monitoring and automation as a foundational aspect of smart grids. This is a fantastic chart here. Now, please don't try and read the text here. It's too small and it's too detailed. But the point I'm trying to make is, given where we're starting from, we need to build up. So we build up from foundational technologies. Those are things like data visibility, metering, managing outages, all the way up to things like demand response, flexibility, sharing information with customers, and so on. This is a chart that I've taken from my colleagues at the CanMet Labs in Varennes. And this is again publicly available on the internet, and there's a lot more context in that report. So just going back to the smart grid program quickly, I won't spend too long on this slide, but the question here is who participated. So we've got a healthy mix of system operators, vertically integrated utilities. Again, depending on where you are in the country, these terms sometimes change, and then distribution companies. So as you can see from this, a lot of the focus was on distribution companies. The majority were distribution, and they operated on the distribution grid, which is why the whole topic of smart grids is so important. Moving on to some of the challenges here that they faced. Of course, the previous smart grid program spanned the 3 years of shutdowns and the pandemic. So some of the challenges were things like well, staff and workforce for one, but also project management and logistics. And you see that here in many of our demonstration projects, we ran into delays due to supply chain issues and folks being able to get out to sites and actually get work done. But these two issues showed up in all three kinds of projects we had: deployment, demonstration, and hybrid. Hybrid being a mix of the two. There's the one other issue I'll point here is that we also saw some challenges with regulatory issues. These showed up particularly in deployment projects and hybrid projects. The example I'll point to specifically is if I want to sell solar electricity, solar energy to my neighbor, the framework doesn't really exist in much of the country. So, although it's technically possible, the regulations don't exist. I'll point to some of the our insights here quickly, and I'll keep the slide up for a couple of seconds, but I'll speak to it on in a couple of slides. Some challenges are technology related, some are market, some are regulatory, but often what we've seen is that technology is not the bottleneck. Often it is the lack of a market not existing and the regulations not existing. So I'm going back to that example of selling energy from rooftop solar. If the market doesn't exist, it's functionally not possible. And for something like trading energy on the distribution grid, we also need involvement of codes and standards. The other major piece here is markets. Designing a good market needs capacity and experience, and that's why at NRCan we like to fund these things through demonstrations. One specific project I'll point to from the Smart Grid program was the IESO's non-wires alternative project, and that was in I believe it was in I'm forgetting which suburb of Toronto, but it is one suburb of Toronto, where the idea was essentially an energy market at the distribution level. So a lot of the info is public. You can also find it on NRCan's website. There's a broad question here next to why any of this is even necessary. Why should you care about smart grid investments? There's a couple of points I'll make here quickly. One is optimizing existing assets on the system. So I started with the question of how much more electricity do we need? The answer is probably somewhere between 1 and 3 times what we have today, but it is more than what we have today. So one solution is if you need more energy, just get it from the transmission system. The other is, well, maybe get some of it from the distribution system. So that leads to the question of if you are getting things from the distribution system, how do you optimize the assets you have? Whether it's poles or wires, maybe whether it's monitoring equipment, whether it's generation, all of this needs to be optimized for lowest cost. One good example here is non-wires alternatives, and this avoids investments in traditional infrastructure and allows you to better use what you already have. Um, the final factor here is smart grid solutions. I did say that we are talking about human behavior here, so it's important that we look at the community and customer focus angles. What's in it for someone to allow, say, my utility to control my thermostat? Why should I care? Why should I do any of that? So this is an important part of the transition. I've got these are my last two slides, and there's essentially one point I'm making here, which is something I mentioned earlier. Innovation is often more than just offsetting technology risk. Technology is one slice of the pie, but it's not the whole thing. There's often a lot more that includes things like the uh, the ability to adopt a solution. So if I'm selling energy to my neighbor, how do I get that working at scale? If it's just me, that's great for a demonstration. But if you're talking about 1,000 people like me, you then need a market, you then need regulations, and that's where you end up with the institutional ecosystem piece, which is policy, rules, and finally legislation. The last slide I have is aligning all of this is really important, and this is key to innovation. So you have to align incentives for technology, markets, and policy. And in between all of this are things like business models. So if my utility wants me to sell energy to them, what's their business model? What is in it for me? What do I need? What technologies do I need to participate? And then how does all of that affect system operation? So all of these are key, and innovation is it is difficult. I'm not saying it's easy, but there's more to it than simply technology. So that's a snapshot of some of the work we are doing at NRCan. I pointed to a couple of projects, and yeah, the one message I want to leave you with is we are a major focus for us is aligning these three areas: technology, markets, and policy. So I'll stop there. I should be close to my 15-minute limit.
Well, thank you very much, Eldridge. You're right on time, so that's appreciated. So I'll pass it over to Hisham.
So good afternoon, everybody. I'm going to be working through sharing my slides. So give me 1 second. Can you hear me clearly, by the way?
I can hear you.
Thank you very much. Do let me know if you can see my screen. Just a thumbs up or thumbs down will be very helpful. Can you see my screen?
Yes.
Perfect. So good afternoon, everybody. My name is Hisham Amara. I'm the Vice President of Grid Modernization at Electra. I've been in this role for about a year and a half now, with a focus predominantly on transforming or how we're going to manage the transformation of our grid, basically, and how we're going to modernize it and moving beyond just trials and pilots into business as usual. So today I'll walk you through a snapshot of what grid modernization means for Electra, but also for the wider sector, and some of the challenges we're going to be facing over the next 10 years, and how we're endeavoring to tackle them. So, sorry, skip it over. So one of the first things we want to talk about, I think Eldridge kind of alluded to, is that there's an evolution that's happening within our sector right now. We're moving away from the old model of one way of power, big generators, transmission, down to distribution, you get a bill. And now what we're seeing is a bit of a what we call bidirectional power. So more DERs, more energy being pumped on the distribution side. And now you have to deal with the dynamic nature of that, which is basically two ways of power flowing, both from the consumer side, but also the generation side. And how do you address this? And now we're going to slowly move towards what we call tomorrow/today model of a transactive energy framework, in which you're going to have multiple players who are transacting with each other, not only energy, but services, information, and otherwise. And how we're going to have to deal with that, both from a technical point of view, in terms of ensuring grid stability on the distribution side for the wider grid, but also in terms of enabling, as alluded to, business models. New business models are going to allow our customers to engage with us through the grid itself. And now this kind of moves into why this is kind of important. So I think some of the challenges we're kind of facing as we're having bidirectional, multi-directional energy, which introduces more complexity. And that's important to understand because our operational frameworks are predicated on a one-way power flow. How do we engage with a way that's actually multi-way? And what does that mean in terms of changing our approaches? The second part is also we're being aggressively requested to accommodate a significant amount of DERs and renewables in the system right now. And the cost of reinforcing the system to enable that, not only on the generation side, but also as we're pivoting multiple vectors of energy from their core competency to electricity, basically cars moving to EVs and potentially heating, the cost of reinforcements is significant. So if you look at Ontario alone, they're estimating $375 billion to $425 billion worth of cost just to meet the 2050 targets. And that does not include distribution costs. So that was estimated by the ISO, just focusing just on transmission and generation. That's a significant amount of money. And that is going to require us to pivot away from a very centralized approach of managing these things to a decentralized approach with the customer at the heart of the supply chain. Now, that presents us a number of challenges. I think the first one is, with the moniker of money, number one, can we actually access the capital? to undertake that work? B, is there even a robust supply chain and enough assets that are going to be able to facilitate that? And 3, do we have the right competencies to execute? Those are 3 significant challenges associated with all of this. And at the same time, we have to keep the lights on. How do you manage all of these things? And this is where grid modernization comes to the heart of it. Now, to understand what we need to do to address this, I think we have to kind of break it down into a number of different key challenges and start from the beginning base foundation. The first one is recognizing that our grid is blind, aging, and somewhat congested and is going to become more congested. To address some of these things, we first have to start with the basic foundation. We need to get better visibility on our system. How do we do this? How do we understand where the DERs are? What are the voltage levels in our systems? How much capacity is happening? What's the hosting capacity? What's the real power? What's the losses? How much unbalancing we have in our phases? All of that, we have to get a certain level of visibility at first. And this is going to be an art that we have to start mastering. It's not going to, we can telemetrize the system, but that's a very costly endeavor. So there has to be a measure, a kind of a balance between putting technology in the system and also having analytics and, excuse me, within the control room to facilitate that. Once we've achieved a level of visibility, then we start getting into a level of control. Controlling the system, whether it's switching, topology changes, power quality, ramping, voltage management, dispatching. But that kind of leads to a second question. It's like, if you're controlling something, then why not optimize? Now, how are we going to optimize is going to depend on what frameworks we create. So what are we optimizing for? Is it a time domain based issue? Is it locational based issues? Is it a capacity based issue? What are the optimizations? That's really important for the utilities to kind of understand what that actually is. And to be able to kind of ascertain what the actual optimization requirement is, you need to understand the value of that optimization. And that's an area that we as a utility sector have not yet, especially the solutions that have actually mastered. How do you determine the value of an optimization based on a location or anything within the utility? What is the value of avoiding a megawatt at this location at this time? What is the monetary value for it? That's really important. And who does that value actually gets assigned to? Is it for the customer, to the LDC itself, the local distribution company, transmission company, generation system operator? So unpacking that and understanding that is really important because it leads to the next point. The moment you understand the value, then you can start creating new business models that can allow you to extract that value. Because that's really important. It's not only about understanding the value itself, it's ability to animate that value. And this is something really imperative because we're getting more and more of our customers who want to become prosumers, who want to become more actively engaged in the grid. And for us to facilitate that, we need to, from a fundamental point of view, understand the value of the services for ourselves as a utility, so we can actually animate it to our customers. Now, that's really important in keeping in mind the fact there's a couple of challenges that are forcing the system to reach its limits. As I mentioned, there's aging infrastructure, you have DERs coming in the system, a large numbers are going to come in, and more it's actually going to happen on the system because the costs are drivers are pushing the cost down. You have an uptake of electric vehicles. I actually am looking at an electric vehicle right now for myself. So there's actually an significant uptake. We're going to anticipate. The question is, what is that hockey curve going to look like? And there's a growth of demand in the system. While energy efficiency has driven down some demands, now we're slowly seeing that demand curve actually creeping up that we're going to have to face. Now, what that really means for us as a utility sector is ultimately a fundamental shift in how we operate. We have our base foundational systems. You have your asset models, you have your engineering tools, you have your SCADA, your DERMS, your GIS, a wide breadth of technology. But then I think we need to start looking at how we operate differently. We need to kind of look at it from a stacked approach. The first thing I kind of alluded to earlier, getting situational awareness, full visibility on the system on our side, and be able to deal with the complexity of the power plant there. Once that's set, then we can start looking at constraint management, then system optimization, and ultimately creating a transactive model. And that's important. How do you animate all of those values into our market? There's different things: locational marginal price, D values, market model-driven pricing, variety of different things. But that really alludes to the level of control and operations we have to actually get into. And this will fundamentally impact how we do planning. We can no longer work with worst-case scenario planning. We have to pivot from a deterministic way of doing planning to a probabilistic risk way of doing planning. Especially if you're going to look at NWAs. To be able to look at an NWA, you have to be able to evaluate it vis-a-vis a traditional solution. And to do so, you have to pivot away from worst-case scenario planning framework. So how do you create that? How do you quantify risk within that framework? And then how do you translate that into a value-added model that you animate in the market? And then once that is captured, you facilitate that through a control room. That operation and that kind of sequential approach hasn't yet been fully fledged out within, at least the utilities within North America. In the European framework, they're a bit further ahead of us, but in North America, this hasn't been a framework that's really been advanced. Now, the other part that we kind of have to focus on, these are some of the challenges we kind of look at, is what level of autonomous control and intelligence are we going to have within our system? So as we're adding more and more analytics, the discussion of AI and ML, and I appreciate the fact that those terms have been eroding with everybody using them haphazardly within all the discussions and all the pitches you've probably heard. But generally speaking, we have two areas of and elements we have to kind of understand. The first one is the level of autonomy we're going to have to assign to our systems. We can't bombard the control room engineers and others with a plethora of information that's going to cause paralysis by analysis here. We have to get to a point in which we have to allow for an element of traditional co-piloting. What does that mean? We already have some of that here with the automatic switching, fluids, and others, but to what level and degree we're going to allow for that? That's really important for us to kind of discover and understand. That's the first part. The second part is, where's the locus of control? Are we going to facilitate all the control through a centralized mechanism for control? Or are we going to have different locuses of control within the grid? Are we going to put smarter intelligence within the substation that are going to control things downstream? And what does that look like? And what's that level of control going to be assigned to them? And how vis-a-vis is going to work back with the control itself? And that's really important. It goes beyond just creating ADMS and all this. It's about an operating philosophy. And I think in the sector, this is where we have to work diligently to kind of put out that framework and understand what that functionality is and challenge the vendors to facilitate it on our end. And some vendors are willing to work as partners with utilities in this space, but I think it's an important part to kind of really frame that argument very clearly. Now, how we're approaching all of this within a lecture, and I have two more slides after this, so I'm going to be quite succinct as well. Is we're looking at modernization on multiple levels across three vectors: technology, operations, and economy. And we're starting with its first and foremost basic elements from a technical point of view: distribution automation, substation automation, leveling and getting the right level of automation in our system to facilitate better reliability, creating a future-proof control room, recognizing that investments we're making in a control room now is going to have to last 15, 20 years. So what is the functionality not only today, but for tomorrow and the day after tomorrow, building that out. Now, from an operational point of view, is getting ahead of an architecture. So our technology, we have a multitude of systems. How are they going to all fit together? We can't look at the old way of point-to-point integration. We have to develop an enterprise architecture to the way we approach all our systems. The second part is also we have to get a handle around our data. That's an area of significant weakness. We have a variety of siloed systems that don't talk to each other. They use different data constructs, different frameworks, and they don't link together. There isn't a single system that gives you a full view of everything happening across the system. We need to build that. We need to build a comprehensive approach across all our operational data. So we have that single panel of glass that we can look at our data, step through our data through time, drill down through the data to be able to build analytics on top of that. And without mastering our data, we're going to be crippled moving forward, especially in an age in which we're moving to AI in that space. Without that, we can't do it. And the next part is also preparing to become a distribution system operator. And I'm going to speak to what that actually is in the next slides. The second level, once we've achieved that, is looking at distribution intelligence. So edge intelligence, we kind of alluded to, like locuses of control, EV management, how we're going to manage those EVs in our space. What does that look like? Designing those programs, building enhanced power flow analytics and advanced modeling. So getting into actually having power flow in the loop in real time, accurate state estimation. We have to also understand the value of VRs and the value of services that mean to us, which kind of move to a fundamental approach of we have to look at it being operated as planned and planned as operated, and enhanced forecasting. Once we've achieved these levels, we start getting into other things: a total VSO framework, stochastic-based decision-making, and an element of distributed control and centralized coordination on our end with a real-time techno-economic operations on the distribution side. So there's a lot there to tackle over the next 10 years on our end. And I think different utilities at different edges have kind of made different levels of engagements and enhancements on that front. What I would say as a cautionary note, I don't think we should forget the data at all. That is really a fundamental building block, and I think utilities have to start striking at that. And there have been, along with Electra, other utilities have looked at this within the United States and also in Europe to start addressing this issue moving forward. Now, in my remaining time, I'm going to speak on DSOs. So there's been a discussion about the pivoting the utilities of that. We are no longer going to be owners of poles and wires. We have to start enabling more customers and more prosumers participation in the marketplace, not only for our own services, but for wholesale services. And that's going to require us pivoting away from just being purely owners of poles and wires to becoming basically distribution system operators. And that means we have to take on more of a system operator role, creation of markets, market settlements, enabling animating market services, and coordinating with system operator. Now, why that topic is becoming very kind of acutely of a focus in Ontario is because the system operator, under its market vision design program, would like DR participation in the wholesale market, and they're going to drop the threshold to 100 kilowatts by 2028. Most of those assets are going to reside in the system, and that's why there's a mandate for us not only to look at enabling them, but also there's a push from the system, from the OABR regulator in Ontario to start looking at more NWAs, the ability to buy third-party services from DR owners. So that means we have to start pivoting to that market construct that we have to start building. And I think that's really important for us. We need to start looking at what that actually means, the ability to not only enable DRs to participate for local services, but the system operation services, and for us to animate those services, and also be able to coordinate with the system operators at all levels across these things. So it's required a lot of engagement on all fronts from our end. There's a lot of challenges. There's a lot of work we're undertaking here, but I think there is a view of addressing a lot of these challenges through an intelligent way of deploying our capital. One of the best ways of actually being addressing, let's say, energy issues globally is actually not building less and extracting more value out of existing assets by being intelligent in how we deploy capital. Thank you very much. I'm looking forward to any questions you have, and I appreciate the time and opportunity to speak to you.
Well, thank you very much, Hisham. You're also right on schedule, so we'll go directly to Ron, and then we should have a good time for the question and answer period. So over to you, Ron.
Thank you. And hello, everybody. Very glad to meet with you. I'll just bring up my screen. Yeah. All right. Everybody can see a black screen, or a black screen that says Decibel plus CAE?
Yes.
Yes, we're good. Well, I like the structure of this webinar. We're going from the macro to the micro, and I'm at the micro end. I'm going to talk about residential consumer endpoints in the network and some of the changes that are going on there and how they're being felt across the network and beyond. Now, Oscar, you had asked for a little bit of self-introduction, so I'll just deviate for a moment. My background is McGill Engineering, MBA in international business. In the first 10 years of my career, I built, basically I worked on thermal and nuclear power plants across the Americas for one of the big players in that area. And then for the following 25 years, I built and worked on similar and other industrial projects around the world. I spent a lot of time in international markets. And it was during this time in international markets, I came to realize that there was about 1 billion people out there that had no access to electricity. And it did shock me a bit. And I realized that these were people that had either been failed by the big grid solutions, or they were simply not accessible, not economically accessible to extend the big grid out to these people. And I came to the conclusion that really the only solution was distributed technologies being technologies that are at a scale and price point that they can be afforded by a family or a small business or a community to really bring solutions to problems that are absolutely critical to quality of life. People that are living without electricity, that are struggling to get clean water, that are living in an environment littered with their own waste and the waste of others is really, it is the worst situation imaginable. So in 2004, I started putting my money where my mouth is and started investing in the development of distributed technologies, first in the area of water and waste management. And once again, in 2014, when I met some like-minded people, and we invested in Decibel, which is a company that is really specialized in distributed energy resources. And I would say the how to advance distributed energy resources. I would say there, many of us lived through the period of at the time when data processing was mainframe computers and dumb terminals. And if you remember that period, you also remember the arrival of desktop computers and laptop computers and now smartphones, as the power of data processing really shifted away from the mainframes and into the hands of the end users. And we're seeing, in some ways, a parallel to that today in the electric distribution sector, as with the arrival of solar panels, with the arrival of residential batteries, and with the arrival of electric vehicles, all of a sudden we have end users that are no longer just consumers. They're actually producer consumers, or actually the term is prosumers, people that are able to generate power, store power, trade power, and also generate and trade data. And this is this shift once again in capability is driving certainly change at the residential level, but this is also driving change across the network. And the change is not small. Let me just hang on. All right.
Yeah, we should go to slideshow format here.
Yeah, I'm not sure I can. Here we go. All right. So the slide, just let me put this aside a little bit. The change is not small when one looks at the numbers. Every day, there's about, in the United States alone, there's about $2 billion worth of fuel, gasoline and diesel that is pumped, or money that comes out of the pockets of the drivers, of the owners, the vehicle owners, through the gas pump and into the pockets of the oil and gas industry. With the arrival of electric vehicles, this revenue stream is gradually shifting over to flowing through, mostly through the residents, actually, because 80% of electric vehicle charging is actually done at the residents, and then into the pockets of the electrical utility industry. Now, this not a lot of people have picked up on this trend, but judging by the volume of negative publicity, negative advertising, negative media against electric vehicles and so on, certainly the oil and gas industry has realized that there is a skirmishes now and a war brewing over this revenue stream. We also have $40 million of residential solar that's going to be installed by 2030. And the residential energy market has now turned into really a technology market rather than a hardware market. In terms of numbers now, the really key number is it a big recurring revenue? If it's not a big recurring revenue, these are fads these are just fads. They are not changes that are going to last. But if you look at the question of the EV charger market, it's going to be about $12.5 billion US in a recurring market. In terms of solar panels, we're looking at about 42 billion annual recurring market. And if you look at the software market, which is part and parcel of the change, that is about actually over 50 billion USD annual recurring market. And these are big numbers, and there is a lot of interest, a lot of industry movement towards this. And it means that the kind of changes that we are starting to see now, the kind of disruption we are kind to see, is growing, and it's here to stay. It'll be with us for a long time. Now, let's for a moment look at the sort of the vision of the home. Here we have a home that is still connected to the grid, and this is the home of the future one, if you want. But it's actually the kind of home we're finding right now in places like California, which are really at the leading edge of what's going on, and we find actually some of these in Europe also. So it's still connected to the grid. It has solar panels. I don't know how many of you are aware, but by law, every new house in California has to have solar panels. You have your stationary battery. You have your electric vehicles. You have grid collaboration with the distribution utility, usually in things like demand response and other type programs. Eventually, this connection can go all the way out to the wholesale energy market, particularly in the U.S., where FERC 2222 now allows the DER, distributed energy resources, installed at the home to actually trade some of their capacities onto the wholesale energy market. This kind of trading is normally done through community aggregation. In California, once again, you have the emergence of a lot of community choice aggregators that are bundling together the resources available from thousands or tens of thousands of houses and beginning to trade this power, either between members of the community or straight out on the energy market. And there are other energy communities that form. But if that's the vision of the future. If you look at what's going on in reality today, you still see the grid here, but you see things like the solar panels are attached to inverters that are attached to the stationary battery, that are attached to inverters, that are attached to a so-called EV charger, which is actually not a charger, it's just a big switch, and which is attached to another converter in the car, and so on. So what we're seeing is a patchwork of technologies, hardware devices that are not integrated and which are not really sharing intelligence. The analogy here is the world of telephoning before the iPhone, where you had your flip phone and you had your Garmin GPS and you had your MP3 player and you had your Palm Pilot, your dictaphone, and even your flashlight. And they were all nice technologies. You needed a big knapsack to carry them all around. But you know, when the iPhone came along, the world changed. Everything was integrated. Everything became efficient in terms of losses between the technologies. There was it addressed all that. And what we're talking about now is the same kind of evolution in the distributed energy resources around the home. We're talking about much more integration, much better integration, much better intelligence. In the case of Decibel, this is our lead product, the first product we're bringing to market. We've named it Ara, and it looks like an EV charger, but it is much more than that. It does connect to your solar panels. It becomes your solar inverter, but it also takes care of the charging and discharging of your stationary battery. It also takes care of bidirectional charging of your car, and it does that by being a DC charger. In other words, it bypasses the AC-DC conversion in the car to directly feed to your car's BMS and car battery. And in doing that, we can also extract energy from your EV battery to feed your home, and eventually, if the necessary permits and are in place, to trade all the way back to the grid, or trade all the way back to the grid. It also handles what we call blackout power. In other words, when the grid goes down, the home can be islanded, and you can call upon your solar panels or your stationary battery or your EV to provide you power to carry you through these blackout periods. And this is actually, we actually thought this would be a sort of a minor feature, but it is, with the increasing frequency of extreme weather events around the world and people sitting for hours or days blacked out when basically during a grid outage. Demand for blackout power is actually very high. We get a lot of calls about this. And on top of it, there is, we bring a great deal more sensoring and processing capability to the home. And by doing that to the home, we actually bring it to the whole distribution network. This solution is also much smaller than just going out and buying the solar inverters, the 15 kilowatts of solar inverters for just a rooftop panel, rooftop array. And there are economies. There's money to be earned every year if you are so inclined.
The sun is our greatest source of energy.
There's a short video here, which I'll just show you what we mean.
Introducing Decibel R16, the home energy station built for the future today. Generating solar power for your home, right through to your EV, and bringing energy back when you need it most. Your home is only as smart as the energy that supplies it. The R16 connects all your energy sources, making thousands of calculations every day to bring you clean energy on autopilot. Decrease energy costs by plugging everything electric into the sun. Our pure DC technology is safer for your battery while providing a faster charge. And when the power goes out, get backup power from your EV's battery. So if you're taking your first steps with solar or thinking about your next EV, get the security of power when you need it most, for you and generations to come.
So there you see the hardware and the way we introduce the hardware to the early adopters, or actually to the general public, and so on. And it is really driven by demand at the level of the individual homeowners. This has nothing to do with regulation or anything else. It is demand coming from the grassroots. Beyond the hardware, we have also developed a lot of software. We have an operating system proprietary to the device that is grid edge computing, that allows you to stay up and running even when the grid is down, and so on. And it also contains the residential marketplace. We have structured this to be a bit like an iPhone, where there is an app store. We are concentrating on the major sources of power and the major sinks of power, if you want, things like the hot water tank and the heat pump and so on. But there are many other devices in the home where we invite people or companies to write apps that they can load onto our Decibel device, and they will then control whatever you want to control: your dishwasher, your power trading, if you want, or how you aggregate, how you trade with your neighbors, and so on. So we are trying to bring an innovative device that will even drive more innovation to at the residential level. We also have the Chorus software, which is our cloud software, and this is the software that delivers you data streams such as the weather specific to your residential location. It delivers you the kind of tariffs that you're going to pay. In many places, you have competing utilities, deregulated markets, if you want, and once you indicate to us which utility you're dealing with, we are able to go and get all of the tariffs. And we use all these to do our optimization calculations to make sure that the homeowner is paying the lowest amount possible for the power they are using at that particular time slot. And we divide the day into thousands of time slots. This is also the cloud that enables the power trading. In other words, it is built almost like to the same levels of security as an ATM network, so that it can safely connect, cyber securely attached to the servers of the utility, and also keep proper track of any financial transactions. Even if they're small, there is a very specific way they have to be validated, and the very, very specific audit trails that have to be put out. So ERA is basically the most sophisticated residential product ever designed. It's backed by a large number of patents, and so on. There's 7 CPUs in it, which makes it extremely intelligent. There are about 330 lines of code, and so on. Hang on, I just have to ship something in the device, driving the device. It does about 250,000 calculations a day, calculations aimed at giving the homeowner the lowest cost of power and the best revenues from trading at any given moment of time. There is the app I mentioned, which opens up the device to others who want to innovate, weather systems and so on. I won't go through it all, but it is an extremely powerful device. So we're going for the situation in the distribution grid where there was a severe lack of good digitization, good instrumentation, to one where there is an extreme amount of it now. There is a really powerful device that everyone can build on. From the homeowner's point of view, manages the energy at home, make sure you're always getting the lowest cost of energy. This is particularly important for people that have very high time of use rates. and so on, and want to be able to save money by managing around them, charge with the sun, particularly if you're driving an EV, generating and storing clean energy for your own needs or for trading purposes, powering your home with your EV, going through blackout powers. This is all on the cost side savings, and on top of it, the possibility of trading power, of trading storage capacity, of trading data, and turning your electricity bill into a revenue stream. We have once again, this talks about the energy marketplace and the enormous potential this now opens up as the homeowner becomes a partner to the legacy utilities, able to be a business partner actually, and respond to various calls, messages from the utility. In the past, when the utility, for instance, wanted to do some demand side management and needed consumption to be turned down, if they called the home, nobody would answer. But now there is someone to answer and someone to act and be the building block for a distribution grid that looks extremely different from the one we have right now. So in terms of benefits now, everybody gets a benefit. From the family residential point of view, there's a greatly increased autonomy and resilience, and then the ability to control power expenses, generate some revenues, reduce the carbon footprint, and so on. These are all positives for the household. From the utility point of view, the increase of digitization is important. This allows better feeder load forecasting. This allows better asset investment planning. One of the things we do is we also use in some parts of artificial intelligence. We use machine learning, but we also use digital twinning. We are able to digital twin a house before any investment is made in DER for the house, to tell them exactly what the optimal combination of DER should be. We are able to, with only a few decibels on a feeder, we're able to digitally twin a complete feeder to restore the accuracy of the digital loads forecasted that is worth money to the utility, to have more accuracy, or to restore the accuracy of those forecasts. Accuracy which was lost after people started installing solar generation and storage behind the meter. We were also able to even digitally twin complete service regions for utilities to help them do more data-driven asset investment planning. From the community point of view, the better data also means there's better tools to figure out how to provide affordable power for everyone. And this goes back to some of my experience in international markets. There is power must not be just for the wealthy people. Everybody in the community must be able to benefit, and programs must be structured and put in place to make that a reality, because the correlation between access to affordable power and quality of life is very high. If you don't have access to affordable power, you are seriously disadvantaged. Finally, from the planet point of view, grid decarbonization is an important way to fight climate change. Right now, a lot of the decarbonization solutions involve building more transmission lines or building large new power stations that use lower carbon emissions, let's say. In our case, if we can take a simple example, if we can deploy 1 million of these units out into the community, this would represent an investment of roughly $20 billion into into decarbonization of the grid, both at the home level and at the utility level. And this is an investment money that can be mobilized by 2026, 2027. In other words, something that can be done much more quickly than any of the other solutions that are out there. And it's what we need now. We need speed and we need scale to really move the needle on climate change. So I think with this palette, if you want, of benefits, that we have something that will move ahead. And I don't want to pick fights, but there was You know, there was kind of an attitude that you need regulation before you can get solutions. And I must say, as an innovator, I disagree with that. Innovation leads regulation. And if you don't have innovation out in front of regulation, or if you have only regulation, you will never get innovation. And sometimes you just have to break the rules or bend the rules or put pressure on the rules if we're going to move ahead. So on that, thank you very much.
Well, thank you very much, Ron. Three excellent presentations. I should have mentioned at the outset that this webinar goes to 2:15. So we're still looking for questions in the Q&A session, but I would like to open up with a general question to the three presenters. Thank you very much for excellent presentations. In the presentations, we've talked about a lot of things, the technology development, and Ron has given an example of something that is very creative and is now being applied in places like California and elsewhere. There's a question of public acceptance, market mechanisms, inadequate market mechanisms, regulatory support, the control systems, the role of artificial intelligence, for asset management and for improved decision making and so on. So when we look at this in a Canadian context, we're obviously not as advanced as in terms of developing and applying smart grid and innovation and distribution innovation as in California in particular, but also some of the European countries. So my question is, given all of the things that need to change, where should we be placing priorities? Okay, what is the most important thing? You know, I think we've all made the case that this is an opportunity for reducing costs, for having taking advantage of new technologies and so on, and particularly with regard to how do we create the market mechanisms to make this work. So where's the priority? You know, this is a question really from the academy, because if we could be a catalyst for things to move forward, we'd be happy to do that. So if I could ask each of the presenters, starting with Eldridge.
That is a very good question, Oscar. I can take a stab at answering that. Obviously, my answer is biased in some sense by the work I do, but I tend to believe that a good first step is trying things. Just trying things, see what works, and then based on that, once you've got data and real world experience to work with, then build from there. So in that sense, I tend to agree with the point that Ron ended with, which is innovation in many ways has to be ahead of regulation. And that's something that we try and do with the Smart Grid program as well, which is to try things, see what works, see what doesn't work, depending on where you are in the country, what your regulatory environment looks like, what markets you have, see what's possible, push that envelope a little bit, and then see, based on that, what your next steps are.
Okay, thank you. So Hisham.
Thanks. Apologies. My computer is restarting, so I have to revert to my phone, so that's why you can't see me. But to kind of answer the question, well, I do agree the fact that you have to have technology leading in innovation, leading in the sense of trying stuff. We've been trying a lot of things in Canada for a while. I think the question really comes to why hasn't none of this moved to business as usual? And the ultimate answer to that is the fact that our regulation prevents it. We have regulation that enables a wrong activity. So if we take an example on the utility distribution side, the utilities are fully incentivized to build capital. That's the only way they make a rate of return. There is not a framework to allow them, number one, to invest in innovation in a way that allows them to improve things. If you take an example of a regulatory environment that did that is Rio in the United Kingdom. Innovation was so core to them that they have $70 million a year allocated for innovation work within the utility sector, funded by the regulator. We're not seeing any of that here. So that's the first part. The second part is, if you want us to change the way we do things, you need to kind of remove the shackles on the utilities. And being a capital intensive frameworks that we have in regulation is limiting. But why does it make a difference how we make money? The utility should be rewarded for ensuring that they find the least cost, irrespective of its capital or OPEX. So I think one of the areas we really need to focus on is how do you incentivize the players in the space who are a monopoly by nature to actually innovate, to actually find incentive, kind of creative solutions. And to do so, you need to actually put innovation as part of the framework of regulation. That's the number one, to make it an act, and actually put money towards it, not simple $1 million or $2 million a year that we see, actual sufficient money in there. The second part is we have to pivot away from a capital intensive regulatory framework to a TOTEX incentive framework in which we look at utilities based on the outcomes they provide, not how they execute it. Let the utilities figure out how, and once that envelope is opened up, you're going to see significant amount of innovation because the art of the possible becomes possible.
So maybe a supplementary question before I turn to Ron, Hisham, is the energy market, as I understand from Ron's presentation, California has moved quickly to create an energy market that has the support of the regulator. Do you see that as being an important initiative in Canada?
So I do perceive that it is something that we could do. And the question comes down to, like, if you look at the UK, for example, by allowing the utilities to move to a TOTEX framework, now they're procuring flexibility services to offset capital expenditure. And now the amount they procured last year is 3.7 gigawatts of local distribution services to offset local distribution needs. That's the level of procurement they went through because of that regulatory change and opening up that avenue. Incentivize utilities to go find innovative solutions, moving away from a capital incentive framework and allowing them to create those localized markets because they can still make their money. They're not tied down to just building. And I think if we move in that direction, you're going to see the innovation doors open up. And just to kind of end on a note, I work for a company called Opus One for 4 years. That company basically did 95% of all its business outside of Canada, and it got eventually bought out by GE. That should be an indication that a company based out of Richmond Hill, Ontario, could not sell to the adjacent utilities in its market, but could fly across the Atlantic to the UK, to Germany, to Australia, and sell there. And I think that's an indication to how we have failed as a sector to open up those doorways because we're predicated on, how would I say, archaic regulatory frameworks.
So, Ron, with your passionate appeal at the end, and you have most of your experience.
I must say the points raised by the other speakers are all excellent points. They're right, spot on. And
Yes.
I'll just add in a little bit of input from the grassroots level. We don't advertise yet, because we're just beginning commercialization, but we get calls from people, and the calls are like, my electricity bill is too high, and I live in San Diego, and at the supper hour I have to pay 81 cents a kilowatt hour for my power, because that's the time of use rates in San Diego at the supper hour. And they say the other thing is they phone up and say, well, look, this is the second time this month I've lost the contents of my freezer. That's $300-400 worth of meat gone, simply because there was what they call a public safety public safety something shutdown. Anyway, they shut down power lines because the Santa Ana winds are blowing a little strong, and there's a chance that sparks will start a wildfire. And this is a huge irritant to people. And we get calls from Texas during the ice storm there. I'm freezing to death. I got solar panels and I'm freezing to death because I can't run my solar panels when the grid is down. This is, people are trying to be autonomous, but they're blocked by, in this case, it's technology and regulation. It's all this. This is different ways of saying that we need a better framework. There's only two ways you increase GDP, the quality of life in a country, and in Canada is a case in point. You either have productivity gains or you have immigration gains. And immigration gains in Canada they're there, but they're limited, and productivity gains are next to zero. And why are our productivity gains next to zero? Well, it's because we tend to suppress innovation in our economy. We have too many monopolies, too many oligopolies. We need the stress and the pressure of competition to really get people thinking, oriented, pushing hard for these improvements. Certainly, that's more. Certainly, the flavor we see in the U.S. is the competition is much higher. It's higher than Canada, and you do get a different different outcomes if you want, because U.S. productivity is what it's running almost 4% now, and I mean if we around 4% of productivity gain in Canada, we would be way better off. So it's
Okay.
these are all points weaving around the same theme.
So we have a question from Tom Brown. Can you comment on the role of provincial utilities? Power is a provincial responsibility under the Constitution. So I'd like to have you address this, Eldridge, because you're the one who raised it in your presentation, and the federal government has certain things that they can do, but I think if you could respond to that, that would be great.
Yeah, that's absolutely right. The electricity sector is a provincial responsibility, and this is where the provincial utilities become extremely important. There's a combination of things here. There is what the utilities are allowed to do, and then there is what they can do. So to Ron's point, in some cases, I think, unless I'm wrong, it's most provinces, the electricity distributor, even if you have a vertically integrated utility, electricity distribution, it is literally illegal to do anything other than distributing electricity. So, for example, you cannot run an electricity market at the distribution level, because that's what regulation says. That's how your local utilities are run, and that's what they're legally allowed to do. So that's back to the original question. The role of your provincial utility here is absolutely critical, because they are the ones that you connect to. They are the ones who, provided something is possible, it's their faces and their responsibility to keep your lights on. So when the lights go on the blink, you will chase them down. So those are the folks who really matter. Um, I'm, that's my attempt at an answer. Hopefully
Okay,
that
well,
goes
thank you.
very well.
So we've basically run out of time. So what I would like each of the three presenters to do is a 30-second key message from your perspective. So beginning with you, Eldridge.
The 30-second message is, we are trying to do innovation, but innovation is complicated. It involves a lot more than just technology. In many cases, it is regulations and policy as well. That's a lot less than 30 seconds, but I'll stop there.
No, Hisham.
So I agree with Aldridge. I think innovation is really critical, and I think with the change that we're facing, we need to have all hands on deck in terms of not only allowing for innovation and giving it breathing room and allowing it to fail. Ultimately, we need to allow innovation to fail, because without that, that's not innovation. That's a high school experiment. So we need to have that innovation and give it that breathing room. And the innovation has to move ahead beyond just technology. It has to be regulatory and market, and we need to have the regulatory frameworks to facilitate that. I think, and we have to put the money behind it, or else we're going to be faced with a significant investment avalanche that we can't match because we failed to innovate.
So, Ron, you have the final comment.
Well, I guess from my point of view, it's grassroots power. We're all living in democracies here. The regulation has, it eventually gets up into our legislative assemblies or parliaments or whatever, and these are to some degree the wrong places to make decisions about something as technical as electricity and as important to individual people. So I think getting the individual's voice out there is an important part. And the way to get the individual's voice out there is people grab the benefits they need. They have the power to put them in, especially behind the meter. And let's exercise that power to affect change. And we're all the better off for it.
Thank you. So just my closing comments. So first of all, I would like to thank each of the presenters for really outstanding presentations and for your discipline in terms of adhering to the time allotment. So, and also the responses to the queries. I'd like to also express appreciation to all of those who attended today's webinar. And just to let you know that, Christine, I think this is correct, that the webinar will be available on the website. Is that correct? Will be available.
Yes, it will be.
Yeah.
You will.
Okay, so with that, thank you all very much. And the session is now closed.
Thank you all.
Thanks all.